In web development, we kind of take some things for granted, right? Like the build step, that whole process of bundling everything up before you can ship it. But what if? What if that wasn't the only way? Today, we're going to dig into a technology that flips that whole idea on its head. It might just be the start of a runtime revolution.
It's this weird paradox, isn't it? Something every successful engineering team knows all too well. You're shipping features, your user base is growing, you're doing everything right. But actually getting that code out the door, it starts to feel like you're wading through molasses. Your own success literally becomes this anchor holding you back.
And this picture here, it just nails why that happens. We all start with that nice, clean, simple box on the left. The monolith, right? One team, one code base, life is good. But then you add more teams, more features, and that box, it doesn't just get bigger, it gets tangled. It becomes this big, messy web, and the lines between front-end, back-end, and all the different product teams just start to completely blur together. So this growth, it's not just some abstract drawing on a slide, It has real, super frustrating consequences for the folks actually trying to get work done. So let's break down those growing pains.
Okay, first off, your development speed just plummets. I mean, everyone's stepping on each other's toes inside this one giant, complex code base. Then you've got this total lack of isolation. A bug from one team's little feature can start a domino effect, and boom, the whole app goes down. And that just kills team autonomy, right? You can't decide to upgrade a library or ship on your own timeline. Suddenly, every single deployment feels like this high-stakes gamble. And maintenance? Oh man, that becomes a nightmare that just never seems to end.
So naturally, the industry's answer was micro front-ends. Let's break up the monolith, just like we did with microservices on the back end. And on paper, it sounds perfect. But as you might have guessed, it comes with its own, hidden set of problems.
Yeah, that dream of having these independent, super fast-moving teams, it often just crashes right into the reality of a brand new kind of complexity. You've basically traded one big problem for like dozens of smaller interconnected ones.
And this slide, man, it just perfectly captures what you could call the coordination tax. So picture this. You fix a critical bug in a shared component. Sounds simple enough, right? Nope, not at all. Because that component is a build time dependency, you now have to go on this huge treasure hunt to find every single one of the, say, 15 apps that use it. Then you have to rebuild all of them and deploy all of them. Your simple 5-minute fix just exploded into this multi-day cross-company nightmare.
And this right here gets to the absolute heart of the problem. It's all about the difference between build time coupling and runtime resolution. See, traditionally, everything gets locked in stone the second you hit build. But what Nuz is proposing is, well, it's a pretty radical idea. What if the application could put itself together at runtime, like when it's actually running in the user's browser?
Okay, so let's dive into the Nuz philosophy and see how this shift to runtime just completely changes the game. Because really, it's not just another tool. It's a fundamentally different way of thinking about how we assemble web apps. I love this quote. In their own words, Nuz is the runtime package manager for web platform. Just let that sink in for a second. A runtime package manager. We all know package managers for our dev environment, right? Like NPM or Yarn. Nuz wants to be that, but for your application while it's running. So what does that even mean? Well, it means your features, your components, your pages, they aren't all baked into one giant JavaScript file anymore. Instead, your main app is just this super lightweight shell, and it knows how to ask Essential Service, hey, I need the user profile page, and then it just loads it on demand, right from the network. All right, so how does this magic actually work? It really boils down to 3 core concepts. First, you've got packages. Just think of these as your features, right? Self-contained, versioned modules, like a shopping cart component or a search bar. Then there's the registry. This is the central brain of the whole operation. It's the source of truth that keeps track of every single version of every package. And last, you have composers. These are like blueprints or recipes. They tell your app exactly which packages and which versions to grab and stitch together at runtime to create the final experience for the user. Okay, theory is all well and good, but what does this actually look like in the real world? Let's go back to that bug fix, the one that turned into a deployment nightmare, and see how things play out the Nuz way. This comparison is, wow, it's just incredible. On the left, you've got that whole painful process we just talked about. But on the right, that's the Nuz way.
You fix the bug in your component, you publish a new version of that package to the registry, and that's it. You're done. The very next time a user loads any of those apps, the compose file just tells it to grab the new version and bam, the fix is live, instantly, for everyone. And get this, the flip side is just as powerful. Let's say that new version you just pushed has a problem. You don't have to scramble and redeploy 15 old apps, no way. You just go into the registry, update the compose file, and point it back to the last known good version. The rollback is immediate. It's just a config change. Now, this all sounds pretty amazing, maybe even too good to be true. And in engineering, there's no such thing as a silver bullet. So let's have some real talk. Let's look at the hard numbers from a real-world use case and, just as important, the trade-offs you're making.
So where do these numbers come from? They're from a case study on Sendo, which is a huge e-commerce platform in Vietnam. They actually implemented a system based on these exact principles. So this isn't some theoretical lab test. This is from a multi-year, large-scale, in-production system.
Get ready for this. A 12x, a 12-fold improvement in deployment time. So what used to be a 36-minute, super high-stress event became a routine 3-minute publish. Think about that. That fundamentally changes the velocity of your entire dev organization. And check this one out. This one's for all the developers watching. Local builds went from 20 minutes down to 1 minute, a 20x improvement. When you're not trying to build the entire universe every time you make a change on your laptop, you can, actually focus on building your feature. This is just a massive, massive boost for developer productivity and, let's be honest, happiness. Okay, but here's the other side of the coin, the costs. You get that amazing team independence, but the trade-off is a new dependency on the network. Every module has to be fetched, and that can add latency. You get instant updates and rollbacks, but now you have to operate and maintain a registry. That's a new piece of infrastructure. And yeah, debugging a monolith is hard. But trust me, debugging a distributed system that's literally running inside a user's browser, that comes with its own whole new world of challenges. So that brings us to the big question, right? Given those trade-offs, when does an architecture like this actually make sense for your team? Because let's be clear, it's definitely not for everyone. This kind of approach really starts to shine in a few key scenarios. First, large organizations with multiple front-end teams, where that coordination cost we talked about is already a huge pain point. It's also perfect for platforms that need to ship updates all the time. Think e-commerce or a big SaaS product. And if you're building a design system that's being used by dozens of different apps, this is an absolute game changer. Oh, and it's a natural fit for super app architectures, those apps that are basically a collection of many different services all in one place. So I want to leave you with this one thought. For our entire careers, we've been trained to think that updates and deployments are basically the same thing. But a runtime architecture like this forces you to ask a really different question. What if your next update wasn't to deployment at all? What if shipping a critical bug fix or a brand new feature was just a configuration change? How would that fundamentally change the way you and your team build software? At the end of the day, architectures like this are really all about one thing: removing the friction that gets in the way of a great idea reaching the users who need it. It's about empowering developers to build better things, faster, and with more autonomy. So go on, build something great. Thanks so much for tuning in.